I am quite honestly happy he's here. We are honored, quite honestly, to have him with us today. He's very, very busy, so please join me in welcoming Eric Schmidt, Chairman of Google.
I'm delighted to be here. I started my computing career on an IBM 36091, and which is a great machine. Water-cooled, everything you wanted in a computer in the 1960s. When the IBM PC came out, that's what I had. Now, of course, we use lots of ThinkPads. And along the way, I've always had tremendous respect for the underlying architecture and technology folks at IBM. So one day, Sam calls me and says, "We'd like your thoughts about distributed computing." And I said, "Well, I think this. I said, he's a very, very nice guy. And he said, "Well, we've already done those." And then all of a sudden I realized these guys are ahead of me. They've actually thought through the consequences of this new life that we're building. And we immediately organized to partner with the technology and the technologist and the vision from an extraordinarily well-led organization of IBM. So the reason I'm here is to talk a little bit about what that means. Right, what it means to us, to the world, to you, to our joint customers, and so forth. And I wanted to start by talking about information. It is my personal belief that the role of information is underappreciated in politics, business, and in the world, and that the rate of innovation in the internet is increasing. It's accelerating. You have huge new opportunities for all of us together in mobile platforms, right, enterprise businesses, and then the role of information in businesses. And this is a global audience, and of course IBM, being the most global of all corporations, would have a very global reach. I like to think of 4 major experiments in innovation going on in the world. Europe, the sound bites, educated, thoughtful, rule of law, empowering. That's one model. The US, innovative, creative, surprising, individualist, another model. China, monocultural, chaotic, controlling, confronting the individual truths, another model. A 4th model, India, following, accelerating the merging of languages and cultures. All of these are worthy experiments in information. I also believe that the outcome of each of those major societies, which cover 80% or so of the world's population, will be determined by how they embrace information, how they embrace the internet, how they use it, how they use the tools that we're all together building. There are all sorts of interesting examples. Rice is in short supply, which is a terrible world crisis right now. One of the reasons rice is in short supply is that the rice farmers are using mobile phones to discover the world price of rice and discovering that the middlemen are denying them their just profits. Fishermen are on boats trying to figure out which port to go into using, again, mobile data connections to say, can I get a price over here or a better price over there? This is a profound change in everyone's lives, and not just in corporations, in buildings, but with people and the way they think about markets and information and so forth. And we're on the edge of a truly great breakthrough. IBM has been working on this for a long time, much longer than Google has existed, and IBM has figured out that the underlying platform is this server services platform that they have literally been driving to monetization. And I've been looking at breakthroughs, and here's a quote for you. Great breakthroughs are closer to what happens in a floodplain. It's not one idea. A dozen separate tributaries converge, and the rising waters lift the genius high enough so that he or she can see around the conceptual obstructions of the age. So think of this as not a single idea or a single company, but rather a set of rivers that are flowing in, which are getting stronger and stronger, and at some point it all coalesces into a model that becomes so obvious we don't understand why we didn't do it earlier. As a backdrop, the internet, of course, is growing very quickly. 1.3 billion users, on the order of 200 million new users per year, depending on who you ask. And the underlying phenomena here is what I'm going to call the technology base case. Moore's Law. Looks like we've got another 10, 15 years of Moore's Law, CPU performance essentially doubling every 18 months. Even more frightening, from my perspective, is a term called Kreider's law, which says that disk drives, literally the disk capacity, is doubling every 12 months. This is particularly good for IBM's revenues, by the way, because they're going to be the ones putting all this stuff together. And if you think about those two compounding, you have amazing consequences architecturally that will affect all of us in many, many different ways. IBM, by the way, is the author of exabyte, petabyte, xylobyte, so forth and so on, all of the new things, because IBM had to invent the names for the concentration of storage that are projected over the next 5 or 10 years. So with this, the open approach, the open standard approach that the internet has pioneered really has allowed us to go from the 4 networks, including one here in Los Angeles in 1967, to the more than 500 million networks that comprise the internet today. You go from 400 servers in 1983, 500 million servers in July 2007. That scaling is phenomenal. And that scaling occurs because you've got one good thing in technology, it can really replicate very, very quickly. So let's do a little bit of fun. If you assume current growth rates, which is a reasonable assumption based on the last 10 or 20 years, by the year 2019, it'll be possible to have a device that's on your belt or in your purse that will have 85 years of video on it. So you'll never be able to watch all of it. You'll be dead before you finished. I mean, to me, this is like the ultimate frustration device. I really wanted that show, I really wanted to do that, but I'm dead, okay? Or my parents wouldn't let me watch it now when I was young, but now I'm older and I'm not interested in it anymore. You know, you can imagine all these sort of dialogues. I mean, the phenomena, here's another example. 81% of the internet users in Japan access the web from their mobile phones. And just to prove that the Japanese are really wacky, the 3 top books in 2007 in Japan were first delivered on mobile readers, mobile devices, and were only subsequently printed in real bookstores, showing once again the Japanese are ahead of us in everything. So is this our future? Maybe, especially if you spend a lot of time on subways. My point is that the technology enables some things that are surprising. Americans send 1.6 billion text messages per day. God knows what they're about. You know, I never really know. In any case, we have the emergence of this massive shift of computing led by IBM, Google, and a few others. It was really a shift from the desktop-centric model to a network-centric model. You need the server, you need the desktops, and you need the network in between. And we call it cloud computing. There are other terms for it. But to me, this is the story of our lifetime. It is the story that will define our careers and what we do, because this is going to go on for a long time. Now, how many devices are you all carrying right now? How many chargers did you bring on this trip, wherever you came from? How many remote controls do you have sitting in your television room that you cannot quite figure out how to work all together? That's the consequence of being halfway through this. That eventually all that stuff should be on the network. It should all be seamless. It should all just work. Now, you sit there and you go, well, why do I have all these different devices? Well, it's combinatoric. The vendors, the manufacturers build a device, but they can't make sure that everything works. It's an end-to-end problem. So again, if they have a standard, if they have a way in which the network works, then they can just plug into the network and everything works just fine. Again, you say, well, like, what's the cost of this? There have been a lot of studies about this. The estimate is that 6 out of 100 products are returned simply because consumers can't figure out a way to work them. Think about the efficiency, the waste, and so forth from these sorts of design issues. So we do know that convergence will occur in this cloud of servers that is being built by IBM and others. And the original term came from a fellow named Mark Weiser. He called it ubiquitous computing, but it's the same principle. And you really do want to be able to watch things on any device, see information anywhere, and so forth. Here's some example. Wouldn't you want to be able to do a map search on your PC and have the same thing on your mobile phone? Well, you could do that now, but you couldn't do that 5 years ago. So this notion, and in fact, the interesting term is everybody kept saying about convergence. And people concluded that convergence meant that everything went to one device. Exactly wrong. Convergence is everything ends up on one server or set of services in the cloud, and there are many different devices. And excuse the analogy, but it's the best one I could come up with. Women have multiple purses. And they spend their time, they have, this purse for this purse for this, this purse for this. And then they move their contents from one purse to the other. So the analogy here is that you have a set of devices, each of which is very different. It makes perfect sense to use this device here, and this device here, and this device here, and they're quite different from each other. But every time you turn one on, it has exactly the same contents as the other one. This is a much more profound change than you might have originally thought when you thought, oh, cloud computing sounds pretty interesting. So when you think about it, and it depends on the generation, with our young employees at Google, I said to the meeting yesterday, and I said, how many of you have your friends and your photos and so forth all on a social network? Every hand goes up. I suspect that wouldn't be true in this audience. It's certainly not true of me. My hand was not up. How many of you put all of your photos on photo sharing sites? Google offers one. Every hand goes up. Again, I suspect not likely for this audience. It's certainly not true of me. So not only is this vision correct, but people of a certain age view it as obvious. In other words, Eric, why are you giving this speech? That's how profound this change is and how important it is for us to understand. So in this, you could think of it as the electricity model, computing resources shifting to electricity. 100 years ago, people generated their own electric power. Eventually, they started to rely on a grid, which is in fact remarkably reliable. And basically the same thing has occurred around web computing. As an example, we brought out a product called Google Sites in March, which is based on a company we acquired called JotSpot. And what you do is you plug and play, you build your site, you press the button, and there it is. Just immediate authoring. It makes perfect sense if you think about it, because everybody has to have a web presence, and it's all hosted on the Google infrastructure. So the cost of innovation has never been lower, which means there'll be even more entrepreneurs, even more opportunities for you all to go help those innovators learn how to use this new model, which means, of course, we all jointly need to understand it and understand its both limits as well as scale. So to me, the consumers are driving this and corporations are caught. And the corporations are caught because consumers are demanding it and the corporations are not operating quickly enough. They haven't yet mastered how quickly to turnkey things. IBM has done a particularly good job, right, in the application space of trying to do that. There are other companies as well. But it's very, very important that our corporate companies, many of whom you serve or represent, understand that the consumer expectation is very, very high on these sorts of issues. So you can do lots of interesting things. The consumer statistics are quite interesting. There are more than 70 million blogs, more than 120 million blogs that are created daily. I looked at the average, and it appears that the average blog has exactly one reader, which is the writer. So not to worry. I would argue maybe it's two, the reader and the reader's mother, in honor of Mother's Day. But nevertheless, this phenomena is certainly growing. The statistics are really quite alarming, at least to me. 7 million photos are uploaded to our Picasa website photo sharing, which is just one of them every day. And YouTube is particularly disturbing. There are 10 hours of video uploaded to YouTube every minute. So that's the scale of this. This is no longer websites with text and, hey, funny pictures. This is integrated storytelling with video and authoring and so forth to cause some consumer behavior, whether it's information or education or games or so forth and so on. The important thing here is that this cloud computing model really does matter to enterprises. IT departments need to focus on productivity. Google and IBM have a set of applications which are web hosted, which allow you to essentially let somebody run it for you. If you look at the virtualization model that IBM has, they got the model right. That basically it's just much better if architecturally you can virtualize those services and let a set of professionals run it so you can get back to work. The same principle applies for email, web authoring, underlying execution, and all the VM work that they literally invented. So there are many examples of this. At Google is a very strange place, as you can imagine. We have meetings where no one looks at each other. It's sort of a rule. Instead, everyone looks at their computers. And we're talking while everyone is typing and editing all the documents, and all of our products are shareable on the net. So one of the key components of this new network architecture is sharing. So all of a sudden you discover, wham, that changed, this changed, and so forth and so on. My talks are written by people in some random order. And then I have to look at them and say, God, what were they thinking? Our business plans are written this way. I mean, it's just phenomenal. And it's at least creative, if a little bit out of control. This decision-making process is also very different. You can now ask your customers things that you couldn't before. You can trial a product, and you'll get the feedback immediately. All of a sudden, the whole product lifestyle is so much quicker. So all of a sudden, the notion of a 3-year plan and a 1-year plan and so forth can be thrown out of the window by new technologies where you can literally survey your customers the moment one comes out, and you can make the changes along the fly. So if you think about it, it's no longer sets of separate applications. It's integrated apps. For example, you can do chat in our Google Docs, which is our web-hosted services. You can chat inside the document all the time. There are things called Google Gadgets, and again, IBM, and I'll give you some examples of this later, where you can basically embed HTML and JavaScript inside of these things, so they're active documents in the old term of activity. And it takes, on the order of 5 minutes to type these things in and author them and stick them in. So as a result, you can get dynamic access to the world's information. You can, for example, in a spreadsheet, put the lookup feature, which is built into our spreadsheets, and it just does a search. So all of a sudden, all of that corpus of information is now embeddable inside of a spreadsheet. And the spreadsheet auto-loads and does all the right obvious things. What about calendars? Anybody here think calendars are boring? I've always thought calendars were really boring. Well, they're no longer boring, because not only can you cross-link calendars, but we can search all the activities that you care about and dynamically update your calendar, and then you'll discover you really are out of control, and you really are overloaded, and there really are too many things to do in Los Angeles while you're here. My point here is that the computer can help because of sharing and because of the dynamic nature of this new web model, and the kinds of applications that you can make are very interesting. I don't know, lots and lots of examples. I have lots of examples here. Flash animation of data over time. Somebody decided that they were upset, and that, in Switzerland everything runs exactly on time. So the trains have GPSs on them. So we give you a down to the millisecond time estimate of when the train will show up in the train station and exactly where it is on Google Maps all throughout Switzerland. Right? Most other countries don't pay attention that much. They're not that accurate. But in the Swiss, it's down to the millisecond, done as a mashup on top of Google Earth and Google Maps by a programmer who had nothing else to do while he was waiting literally for the train, and annoyed because it was late. We have a platform called Android, which is the expression of all of this in mobile phones, which is in the process of being delivered. And part of it is it's a developer. And somebody said, well, what I'm going to do is I'm going to take my GPS location. And remember, phones are very interesting because phones have CPUs, they have CPUs, memory, they have cameras, and they have GPSs. So what this person did is he wrote an application which says, where am I, what am I looking at, and then let me tell you what you're seeing. So you can put it in a mode where it says, not only this is what I see through my photo lens as a camera, but also I'll tell you what everything is, because I know the landmarks, because I'm integrated with maps. It can also, by the way, tell you where to go. Right? You're lost, turn left, turn right. But it's a very different way of visualizing where you are. Another example, which is particularly scary, there's something called Friend Finder. And what happens is you have to choose this, thank goodness. You choose to let other people know where you are, and it says where the other people are and how to get there fastest. So this thing pops up and it says, all my friends are here, and turn left for this, turn right for that. Again, the off button here is very important. And it shows you the path, shows you the visual, shows you a picture of the person. This is this new geocentric, application-centric cloud computing model before us. Now, IBM, of course, is busy building this architecture inside of a whole bunch of its products, partly because IBM was so forward-looking in its commitment to Linux, so forward-looking in its commitment to Java, and all of the web services now, they've got the head start. The WebSphere Portal product is one. For example, you can basically, using WebSphere, you build these sort of websites. You can embed all these interesting gadgets that I'm talking about right in your application. Now, you sit there and you go, what would I use this for? if you're doing something in manufacturing. Well, it turns out that GPS coordinates and sharing apply to simple consumer applications, but they provide real value in a business context. That's the secret of our collaboration here. And you can do fun stuff like the weather, but if you're in a shipping company, the weather actually matters. In the case of Lotus Notes, we did the same thing. The email reading structure within Lotus Notes, we can now embed the kind of sharing and gadget tags that I'm describing earlier. So the point here is, and a lot of us are jointly developing applications for enterprises, that there's a new layer here. Remember I talked about it as a breakthrough, and this new layer is both exciting, it's sort of what I've done for my whole career, and we're finally getting there, and it's just phenomenal. But it's also challenging for developers. Because if you think about it, the developer now has to think about not just the PC or the mainframe or the Unix server, but they have to think about building things for internet-enabled devices, game consoles, mobile phones, devices, music players, cars, appliances, and so forth and so on. I mean, you're going to have 500 million Wi-Fi chipsets, sold in next year. Think about the Wi-Fi enablement of all of these devices. Just remember that set-top box on top of your television is in fact a computer with an IP address. People can talk to it and they can start having some fun with your television. So my point here is that the architecture that's being built here has to enable more than just one platform being built. And so the developers have to basically build an application that really anticipates these extraordinarily large data sets. I mean, again, go through the numbers, right? The amount of video, the amount of data. Just think of the scale that a developer has to deal with. And this is true of your developers, the people who work for you as well. And they have to basically be willing to execute algorithms across computing clusters. They have to be able to write in languages like Python and other sort of scripting. They have to have distributed data storage, something which IBM literally invented. You have to have distributed data storage where you can actually draw that, and the information is not just on one server, but on multiple servers. And you have to put it all into a single platform. And of course, this all has to be available through the mechanisms of the internet. So what happened after Sam called me and said, let's talk, we sat down and we said, what's the most important thing we need to do right now between the two companies to accelerate this? And they came back and they said, nobody understands this, but the scientists basically in New York, the scientists at Google, and a few other universities. Why don't we build a version of this architecture, this is the clever part, and give it to science? What we'll do is we'll give it to all of the universities, literally worldwide, by the way, not just in the US, and we'll give it to them because, well, it's obviously the right thing to do. Plus, let's be blunt, it'll help IBM and Google because all of those people will get out there and they'll be able to program and build against this new model. So what happened, of course, as a result is that we, after a lot of joint scientific work, we announced an academic cloud computing initiative last October. And what it does is it takes open source, literally IBM and Google do not own any of this, and it builds a set of data centers that are for the public that actually implement this whole computing model. And by the way, it does it at scale. So we started at the University of Washington, we did Carnegie Mellon, MIT, Stanford, the usual suspects, University of California, Berkeley, and University of Maryland. We also then immediately went to Tsinghua University in Beijing and are now going global with a whole bunch of other universities. And in fact, what's interesting about the collaboration, Google and IBM hardware and software architecture and Tivoli as the network management console makes perfect sense. So what are some of the interesting results of this? Somebody figured out a way to build, a 19-year-old, literally physicist, figured out a way to simulate collisions related to the Big Bang that could never have been done before because of the computing resource that was put out literally through this mechanism. Another showing you that intelligence is distributed everywhere. A European 18-year-old developed the largest collection of prime numbers ever using the same infrastructure, sitting in his home in eastern Germany. This scenario has been so popular that it got out of control. And so we eventually asked the National Science Foundation to run this and to actually figure out, there are so many interesting applications for this, we literally couldn't pick the winners anymore. It gives you a sense of the power of the model that I'm talking about, and the sense that we're right on the edge of this taking over almost everything. And I'm very, very proud of what we've done together here to provide for the public something that can actually work on climate modeling, gene sequencing, protein mapping, answering the fundamental questions of whether the Earth is going to be around or is it going to sort of go kaput? The fundamental issues about cures for cancer and other sorts of diseases, all the issues about viral and protein mapping and so forth that are now possible at this level. And you say, well, those are great, but how does that translate into my business? It's the same platform. That's what's so interesting. We get such leverage. So when I think about it, and I think about my history with the IBM 36091, which was a great machine at the time, fastest floating point processor, 1 megabyte was this big. And I think about where we've come today. The key idea here is that computers are not alone, that computers act in networks, that if you can get the architecture right, this cloud computing architecture, if you can get the development layers right, you can build these platforms, and that the platforms are more robust than the one you did yourself, because you get the sharing. They're architected in a way that provide tremendous customer value, and they literally change the world. And that's what's so exciting to be here, to do what I do, to do it with Sam and his team, and frankly, you know, to be here today. So with that, thank you very much.
You were in charge.
Yes, so why don't we make the most of the time we have and get started right away, if we could. And I was very intrigued by the descriptions of cloud computing. And in addition to the specific applications, it seems to me that there's a new model of collaboration here. It's different from the old, you know, we will develop Windows and then people will write software application for Windows. It's different from Linux, which is a non-commercial entity trying to make things available for the world at large. So one of the intriguing questions that was in my mind as I heard these descriptions of this cloud computing initiative is, how does collaboration work when there are two organizations, both with significant resources, somewhat different commercial interests, trying to pool their efforts to get something like this done?
Well, maybe I'll start. You might find it interesting. Eric's heard the story about how we got to IBM, to me calling Eric one day, because it'll get a little bit to your point. We have a meeting once a year in IBM where we argue about the future of technology, and research comes in and takes a provocative view, and the businesses defend, because they're obviously grounded in operating income statements, and research tends to be much more theoretical and farther out. And we had this big debate about the cloud. Is it real? Is it not real? We're doing all this work and research. We had all these tech capabilities that Eric has described. And so we had this big debate. And in the meeting, and we did it differently than you do, Eric, because at IBM, they don't look at they look at each other and yell at each other. So they don't look at their machines. It's like, they gotta look at their face, you know. So they're sort of their face, you know, without the benefit of looking at the screen. And so I remember asking my colleagues the question. I said, well, are we better off with working with someone like Google or not? I mean, we're not really competitors, but you know, it's a different model, different business structure than ours, and what do you think? And they had a long discussion. Anyway, we all concluded the right thing to do, we should just call and just see if they'd be interested in talking with us. And you'd say, well, what led us to this conclusion? I mean, that's what you're looking for, I think. Panjat, the logic, what led us to this conclusion. We really weren't looking to sell Google anything, and that wasn't the thought. But the thought was, if you saw the future, as Eric has described it very, very well, and I won't waste the audience's time re-describing it, but if you really believe that that was a future state, and you believe that it wouldn't be everything, it never is, there'll always be other sorts of things that go on in this computing world that we live in, And there's still a lot of big, large mainframes doing banking transactions every day. But this would complement, if you believed it would complement, right? Who would be the best company to partner with to get something like this at least established, right? And who would that be? And as we thought about it, and a little bit of the comments I made, had to be someone committed to standards, clearly, common points of view of the future that had to align, it wasn't going to work. And the other thing for us is a culture where the teams would come together and work together. Because the engineers at the end of the day, as much as Eric and I might encourage them, at the end of the day, if the engineers don't believe in this stuff, I think in both cultures, I know in the IBM culture, it just won't go. I mean, the engineers have to believe, and the scientists have to believe, or it's very hard to move them down this dimension. So that sort of got us there, but common point of view of the future, committed to standards and open architectures. Actually, and Eric was very kind to us in the conversation, it was Google's idea the best way to get this going was through the academic community. That was really a Google idea.
Well, we think it was your idea.
Oh, okay. I don't think, anyway, maybe the historians will write it was IBM perhaps because you've been kind to us, but fundamentally it was a way, but Eric, no, I mean, the reason why, a little bit I'm going to pass to Eric in a second, because remember you were saying that it's not so much, we have to get people to understand it and train and develop on it, right? And how can we do that? And maybe IBM responded by saying, well, we can get these academic initiatives going because we do these things all the time anyway, as you do. But I think it was you framed the problem that day on the whiteboard. Eric kind of framed this problem with me that day. That led to this next step. So it was that kind of a model that led to the collaboration. And I'll pass it to my colleague.
I was going to say that we've talked to other companies, and why did this one work and none of the other ones worked? I think it's a real question. And all innovation comes bottoms up. And so it's important that you have two things. First, you have to have really smart people who actually are doing the work, which IBM clearly does, and hopefully we do as well. And they have to like one another. That was easy. Right. And the second thing is there has to be a compatible culture. And it turns out that the culture that IBM had set, surprisingly to us, based on sort of prejudice and so forth, and sort of not really knowing it, was really quite compatible with trying to truly change the innovation model. And that's because the leadership let it happen. Other companies will have very smart engineers, but the leadership is either suspicious, or they send large numbers of lawyers to visit us, or so forth and so on, and just everything bogs down.
We have lots of lawyers, though.
So, as an academic, it's
having just left our annual shareholder meeting, I've had a lot of experience with lawyers this week, Eric, so I have a bias right now.
So, as an academic, first of all, it's great to hear that academic customers are considered desirable for certain purposes. And the second thing I can understand...
Exploitive if they are.
It's interesting, by the way, and IBM is again, much too modest. IBM has always been building specialized hardware for universities.
Yeah, we have for years.
Right, and so for example, there was a chess challenge, which IBM ended up winning big time, and IBM was willing to build the very best and fastest hardware. I have no idea why that was a good business for you, Sam, but it was really good from a technological perspective.
Well, I mean, I think the thing, it's like the parallelism of the cloud. We did it in this kind of a server. It was a Unix server against Kasparov. But the logic of it was, and if you think about it, like it's the blue gene, where we do in these massive supercomputers, protein folding and those kinds of, we simulate the nuclear arsenal, et cetera, and those kinds of capabilities, model weather, what have you. But the reason why we do it is for two reasons. One is we believe, to advance the science. Why is it important for IBM to advance the science, right? Not because we've always done it, but beyond that, because we do spend a lot of money doing it, we obviously want to get our returns. But we feel that we're better off being in the forefront of advancing the science or the state of the art of the physics or the computing model or the architectures in an open standards way than trailing in that debate. Now, I mean, quite honestly, we would prefer to have others with us. Universities are key to this, governments are key to this. There aren't as many commercial IT companies anymore who really have fundamental research left. They've all gone down a model of very oriented towards Wall Street, very short-term oriented. But I mean, a PC distributor, you can pick your one, has like 1% in R&D. we have $7 billion a year. So it's a completely different business model, but fundamentally we've come to the conclusion that over time we're better off advancing the field of these computing architectures, and then if we're successful, we get it right, we get the economic benefits associated, versus trailing and having someone else lead. So we've always done this in IBM. If we didn't, the scientists would leave. They'd go to Google. I mean, we have 205,000 engineers and scientists, and I'm convinced if we didn't give them the opportunity to create the future, the people we've hired would find some place to go create the future, because that's the individual that is attracted to a place like that.
So some of it seems to be the compatibility between sort of engineering-oriented cultures, values, interested in pushing things a little bit past where purely commercial short-term optimization would take you. Still, those seem like necessary but not sufficient conditions given the differences in physiognomy that Sam was describing during the course of his talk. So what other lessons can you offer the audience and me in terms of how one makes collaborations work even when the conditions on the ground are fertile, which is obviously a prerequisite for anything like this to work?
Eric made it real. He's very, very modest, but he gave both teams a challenge to come back with a prototype, and it was sort of like mapping and shopping was the example, as I recall it, right, Eric? And so he said, okay, you guys, he defined the challenge to both teams to come together on, work collaboratively on, and say, this is the challenge, come back. He gave us like 8 weeks, the team 8 weeks, we were together. But I think because he had the vision of articulating that challenge, it did a couple things. One, it was a hard technical task to solve the problem, but it also congealed the teams. They got to know each other, they got to respect each other's capabilities, they got to learn from each other. And to me, my observation is once we came back with these prototypes, operational, in fact, you had to go off with a political leader that day, as I recall, they had to leave the meeting a little early. But the teams came together. I mean, they had a lot of respect for each other. Technically, they had respect, and then, quite honestly, I think, we just got out of the way and it ran. Right? We didn't have to do much of anything after that.
I think sometimes you have to show the future. So I'll be talking to somebody, and people are always very polite, and they'll go, yes, yes, yes. And then I discover they haven't really used the internet very much, or they haven't really used social networks very much. So everybody wants to look like they're real experts, but in fact you have to be embedded in it to really understand its implication in your business. So I try to use everything all the time, even if I hate it. Right, and at my age, a fair amount of this stuff makes no sense to me, so nevertheless, I try to force myself to at least understand it, and I think that's a good, for people in the audience, you've got to immerse yourself in it. You've got to use your product. You've got to use the e-commerce site. You've got to buy the product. You've got to understand that. You've got to sit next to it, and if you're not doing the calls, you've got to sit next to the person in the call center and listen to them and experience that with them. You're not going to get the business insights without doing that. It's really about immersion.
So just continuing on with cloud computing for just a minute or two longer, I was wondering, one of the things that I thought I'd heard was that this may lead to a convergence between the enterprise space and the consumer space. Now, historically, IBM and Google have focused on, largely, not entirely, on different portions of that space. How did you think about this possibility of intersecting worlds as you got into this collaboration?
Well, I guess we think about it two different ways. What happens is that we've learned that many of these new technologies start in the consumer space earliest because there's less risk to deployment. I mean, Eric wasn't here this morning, but you heard the CIO panel talking about risk of deployment with all the other things they have to keep buttoned down. Sarbanes-Oxley compliance and all these things. I mean, they're very nervous about experimenting with too much with new technologies. So you see a lot of these things emerge. They tend to, the internet emerged in the academic and the consumer space. Some might argue that the $1 billion we put behind it kind of made it, ready for the enterprise, which was a rather modest investment, but was viewed as large at that point in time. But fundamentally, so we've always been attentive to these sorts of things and try to see if they extend and they can apply. And that's kind of a technology point of view. And then there's obviously the business model dimension there as well. But in the technology point of view, we sort of we're looking at this and saying, okay, is there a logical way that in enterprises they try to get scale and virtualization to do it in their world, we call it behind the firewall, but in a secure way that they can protect the transaction flow and the information identity, et cetera, that you're out there in the public networks doing other things you're sensitive to. Is there a way to do that? So that was sort of observation of technology, how does it apply? And quite honestly, as you look at this blue platform, we're now announcing that hopefully our partners will put their application marketplace on. It is fundamentally a cloud. I mean, we'll operate the cloud. That is what it is, right? We've learned a lot together here. We'll make it available to our partners, and hopefully they can sell on top of that their various kinds of services and offerings. So to us, it's the first instantiation of taking something that was pretty much consumer. We're going to use our own economic purposes with our partners, and also looking at areas, especially a lot of these large enterprises have thousands and thousands of these traffic-based services, just pointing things to the back end, and is there a way to kind of apply the technology there? So that was kind of how we thought about it, as a place to learn that we could then apply elsewhere.
My own prediction is that there will not be that much difference between the consumer architectures and the enterprise architectures. There's one fundamental difference between enterprise and consumers, which is that the enterprise customer will pay for things that the consumer will not, and the enterprise customer has a very real need for greater security and greater quality of service, and that you can build a business where you charge for those, and they're willing to pay for it, and it's a good business decision for them. And again, if I go back to the virtualization that IBM did starting 15 years ago or so, traditional data centers done off-site, you see that IBM has sort of figured out a way to do this. Google is also trying to do this with some lower-level services where, again, they're free for unsupported use, but there's a modest fee for supported use. Right. And that model seems to be coming along. I think it's a new model for the enterprise.
So we've talked a little bit about the enterprise versus consumer worlds. Now to switch to another kind of world, we spent some of the morning talking about globalization. Right. And I wanted to explore that set of issues as well, because one of Sam's themes during his talk was accelerating global integration. On the other hand, we know that there continue to be differences across countries. So what's IBM figured out about how you simultaneously meet the challenge of being locally responsive and relevant versus achieving the kinds of economies of scale that allow you to do better than your local competitors?
It's the business analogy to Eric's comments on these computing architectures. And so what do I mean by that? Well, we've created the cloud of business process. All the back office of IBM is globally integrated. It runs for the entire world. Accounting, HR, procurement, supply chain, all that stuff, right? We don't do it by region anymore. We do it for the world. I mean, and that's how we run ourselves. And we did it for, obviously, efficiency purposes, but we've been years doing it. We have a long way to go, but it's been very productive for us. Now, why is that important? It's important because then you can spend your time in all these, we're going into these 100 new countries. Well, we've been in them for a long time, but we're investing in them. They don't have to deal with all that anymore. So now when we enter, we announced this growth organization. They'll probably at the end of the day we're going to roll it out in July, 50, 60 countries in it today. They've all been growing somewhere between 10 and 30, some 50%. Some are big now, like China and India. Russia's small at 300 or 400 million, maybe on its way to 600 million. So it's not big, right? Others are billions, but the point, Middle East, but the point of it is that what it allows you to do is that those people just worry about what it takes to serve the front end, the client. What skills do you need? What partners do we need? Because we distribute with a lot of people in this room there. It's not just purely IBM. What are those key relationships? What government context do you have to have? What university relationships do you have to have so you're viewed as a valued citizen in all those places? But the cloud takes care of the cloud. I mean, you don't worry about an audit or a payable or a receivable and all that treasury and all that stuff. And so as a result, what it allows you to do is scale a lot faster. I mean, it's a business model that we talked about.
By the way, Sam, you haven't even mentioned that you're doing all of our accounting and payables.
Yeah, that's right, exactly.
And you refuse to tell me which country you're doing them in, and I don't care. I think it's India, but I'm not really quite sure.
I will tell you this, the best audit we've ever had has been in Kuala Lumpur.
Kuala Lumpur?
Kuala Lumpur for payables and receivables. Best ever in the world. No recommendation.
Well, I'm pleased to report to you that we're still happy with the deal we did.
Thank you very much. But so then the other side of it is, and that to your point, the cultural, so that's the business model side of it, right? The cultural side of it is that you have, well, I mean, you have to deal with each of these countries differently. And you have to be able to do that based upon where they are on their societal agendas. And so we have these programs, we got China out, India out, and just Vietnam out, et cetera, et cetera. We're doing the Middle East out. But we look at what are the most important things for that society on the ground. And it varies, over stages of their economic development. And then based upon that, we try to connect in. But, again, we don't have the benefit of a consumer brand, so we can't go launch a ThinkPad in all those countries or whatever anymore. So we try to connect to a societal thing that's very, very important, and then embed ourselves in that economic expansion. Part of the Lenovo deal was our ability to create a Chinese global company that could be a success story for China, and it has been. The government's very happy. Well, because they're very happy, obviously, good things happen for us as a result. So it's this local understanding, connecting to the society's requirements that people do on the ground. They're not burdened with the overhead of the past. They don't have to worry about treasury and data centers and education centers, all that stuff we had to put in 50 years ago. We don't even do it. It's in the business process cloud, with Google and a lot of other people in that cloud doing all that kinds of work.
I was going to offer a simple rule that people around the world are exactly the same. They want exactly the same stuff. They care about their families, they want better health care, they want safety, they want lower taxes, they want cars and so forth and so on. So once you understand that all of the 6 billion people inhabiting our fragile Earth here and growing precipitously, they all want the same things. The only difference is language and some aspects of culture. So once you understand that, you understand that they are, as a group, going to want all of the crazy stuff that we have invented or the things that we've pioneered. They're going to want cars, and they're going to want computers, and they're going to want to do stupid stuff with photos and use YouTube and so forth and so on. So subject to language, we approach the globe as people are pretty much the same. Now the societies differ, but their ultimate driving, the individual, very similar.
So let me just ask a follow-up on that, because my impression is that, say, take something like Orchid. Does well in Iran and Brazil, and I've spent some time trying to figure out the cultural commonalities between Iran and Brazil.
And India.
And India. Right. Doesn't have quite those market shares elsewhere. So what would account for that variation?
We don't really know. It's an interesting question. For those of you who don't know, social networks have evolved with leaders in each country. And social networks tend to be network effect businesses, because if all your friends are on one network, you're likely to join that network as opposed to another. My own view on social networks, and this is controversial, is that they are still too closed, and that the internet says that all societal activity is sort of open, and that eventually these networks will become much more open, and people will move in and out of the networks. So we don't really know why a social network takes over in one country or another. But the important thing is that to say about social networks is that they're real. A lot of people, especially if you have high school kids or college kids, you assume this is some toy that they're playing with. That's certainly all my friends think that. But these are real phenomena of people living their lives online, and it has legs. We're going to have to deal with it as a society.
Well, the clock reads 0, which I take as my cue for trying to wrap things up. So it is very interesting that we started off by talking about network computing and are back to talking about networks in some sense. And I think that's a little bit of a reminder of how just the traditional kind of monolithic view of enterprises and of individuals is something that we've gone past, and why a gathering like this is so important to obviously IBM, but I assume also to all the partners in this audience. So with that, thank you very much.
Great.
Thank you.
Thank you.